In this video, we'll start to explore how do enzymes actually work to bring about the reactions they are supposed to catalyze. Okay, so after this entire video, you should learn about the types of enzyme action. So there's a total of 3 kinds of them. So enzymes actually display 3 of these characteristics. Number 1, they help to speed up reaction. Number 2, they are required in minute amounts. Okay, so minute actually means small amount. Okay, so basically it's trying to tell you that you don't need a lot of enzymes. Just a few of them is enough for the reaction to happen. Third, they are actually very specific in their action. Now, what do we mean by each of them? So let's take a look at some examples. In terms of speeding up chemical reaction, okay, one thing that you must realize is that for a chemical reaction to happen, right, there's something that we call an activation energy. Now, you know that the term activate means to start something, right, to initiate something. So, for instance, if I want to burn this entire forest, right, we know the haze problem that we have right now. Before everything begins, there must be, at the very start, a small energy that allows the fire to begin. And that may come from maybe a matchstick that's been lit on fire, maybe a cigarette butt that was being thrown into the forest, or maybe just a very warm day whereby the sun actually heats up certain leaves and they catch fire, and then the fire will start to spread. Right. So likewise, for a reaction to happen, you need something called an activation energy, a small amount of energy for the reaction to first start. Now, how do enzymes help to speed up the chemical reaction? They do so by lowering the activation energy. Now, if you try to imagine, for a reaction to happen, as you see in your diagram, this person has to push this purple ball across this slope so that the reaction can take place, right? So imagine this is the idea. So what happens is that he actually have to overcome this height in order for the reaction to take place, and this is what we call the activation energy. So there must be enough energy first, so he must overcome this amount of energy first before the ball can roll down. Now, when an enzyme comes along, it helps to lower the entire activation energy. So you think of this as like the slope becomes lower, right? So now the activation energy is actually only like this. So the activation energy actually becomes much smaller, which makes it even easier to start. As a result of that, the speed of the reaction actually increases. So that is what the enzyme is doing. Now, so over here I have some diagrams, okay? So maybe to fill in together with you, let's say that at the start, you actually have the substrates over here. It's lying flat on this slope, okay? On this line. Now, in order for the substrate to go through a reaction, right, it has to overcome a slope, right? So this bigger slope, okay, the black one, actually represents the original activation energy. Now, original activation energy means before the enzyme comes along. Okay, this is the original activation energy. Now, after the enzyme comes along, the red line will actually be the new graph, right? So the activation energy actually changed. So this is with enzyme. And from this entire reaction, you end up with your products over here. Right, so it's a very simple diagram trying to explain to you how before a reaction can start, you must overcome this slope. And with the presence of an enzyme, this slope actually becomes shorter. So this is a lowering of the activation energy. The next characteristics of an enzyme is what we call that is required in minute amounts. Now I've mentioned just now that minute means small quantities, right? So why so? Because enzymes, right, at the end of the reaction, they are actually chemically unchanged, so nothing happens to them, which means that they can be reused over and over again. Hence, you don't need a lot of enzymes for the reaction to start, so a small amount of it is good enough. The third characteristics of enzymes are that they're actually highly specific in action. Now, what do I mean by highly specific in action? Okay, by now you should have realized that when we name an enzyme, right, realize that a particular enzyme can only match a particular kind of substrate, right? So for instance, okay, if you think about it, lactase, this enzyme, can only act on what is the name of the substrate. Is it starch? Is it lipase? Is it maltose? Or is it something else? Right? So based on the naming convention, you should know that it only acts on lactose. Right? And this actually tells you a very important thing, which is that one enzyme, every enzyme can only act on a certain type of reaction. Now, this lactase enzyme definitely cannot act on, say, amino acids, right? Because the name itself doesn't match already. And this kind of specificity, right, can actually be described as what we call the lock and key hypothesis. Okay, if you think about it, when you go home, right, before you open up your door, usually you use your key, right? And your key only matches the lock of your door, right? You cannot open your neighbor doors, or you cannot do any other thing else. So likewise, when you think about an enzyme and how they work, you need to think of them as like a lock and the substrate as a key, whereby the key can only fit into that particular lock, or the lock can only fit into that particular key. So they always come as a set, right? So the shape must match each other's, right, in order for it to work. Now, one way to think of it is like what is shown in this animation. You realize that this enzyme, this blue color shape, actually has a dent in the middle, right? And that dent, just now in the video, you actually see that it's called the active site. We'll talk more about this later on, but you realize that the green substrate can only fit if the shape matches the shape of the active site, right? For instance, if the shape of the substrate today is a triangle shape, it's never going to fit into this entire active site, and the complex will not be formed, and there won't be a reaction, and there's no products. So likewise, if you do a recap now, let's try to practice and see what are the name of the enzyme based on the substrate that it acts on. You try to fill this up by yourself in your notes. And once you're done with it, then we can move on. You can pause the video now if you want to. Now, so just a recap of how the enzyme works. If you recall in this particular video that I showed you all just now, okay, if today you imagine that these substrates are squares, right, no longer the circle shape, then in this case there will not be any reaction, because this enzyme cannot allow these two square shapes to fit into its active site, which is the shape that you see over here, right? And this idea brings across the interesting point that enzymes are very specific. Right? You cannot change the type of substrate. If you change it, it just won't work, right? If you think about it, this highly specific nature of the enzyme is not something that is new to you, because you have been watching this diagram happening over and over again. So you have your enzymes, right? And then there's a shape over here, just that we didn't tell you what's the shape previously. Now, this specific 3D shape is what we call an active site. It's an active site because that's where the reaction actually takes place. So that's where the substrate actually fits in with the enzyme. Now, how do we describe this similarity in the shape? We say that substrate has a shape that is complementary. This is a keyword that you must remember. Complementary means it's the opposite shape. Okay? So only substrates with the shape that's complementary to the active site can fit into it, and this forms the enzyme substrate complex that you know. Alright, so a complementary shape is needed for that to happen. Now, in this complex, the reaction happens and the substrate is being turned into the products. Now, the products will detach from the active site and you will leave the entire reaction, but at the end of everything, the enzyme remains chemically unchanged. This is a very important sequence of events whenever you are describing how an enzyme works. Okay, so if you think about, for instance, this example, lactase acting on lactose. It's a specific shape that has a specific, what we call an active site, right? In order for the reaction to take place, the lactose must have a shape that is complementary to the active site. This will then allow it to fit in nicely into the active site, and then reaction can happen, right? So because the lactose shape is complementary to the shape of the active site of the enzyme, then the complex can be formed, then the reaction happens and the products will be formed. Okay, at the end of everything, the lactase enzyme still stay as the shape that it was in. So let's just have a quick true and false. Okay, so imagine that this is the enzyme. Now, do you think that this substrate can fit into this enzyme? Right, if you look at the shape, you realize that this one cannot. Okay, next, how about this particular substrate? The shape is slightly different from the first one, but will it be able to go through a reaction in this case? And the answer is no again, right? Because the shape is not complementary to the shape of the enzyme. How about this one? Likewise, it's a no. It's a no-brainer in fact, because you realize that all these shapes, so all these end substrate are not complementary to the shape of the active site of the enzyme, right? And as a result, they cannot fit in the enzyme, right? And hence there's no reaction. Okay, good. So now what I need you to do, right, is to take some time now, maybe 10 minutes or so, just to consolidate everything that you learned so far in these first two videos. Write these down onto the summary notes. It's very important that you take this 10 minutes break to consolidate everything you have learned so far. Try to explain every characteristics that you can think of, right? For instance, if enzyme can speed up a chemical reaction, why can they speed up a chemical reaction? Use the keywords that has been taught in this video. Try to write. Okay, the most important thing that you must do in this chapter is practice and practice and practice your writing, so that your ideas can come out in the proper key terms. Okay, and with that, we'll come to the end of this second video.